Hello, ng-conf. How are we excited today? How are we doing? It's Friday afternoon. It's Friday afternoon. We're all getting a little tired of the conference. I'm going to be here with you to get through this talk together, OK? So this is the Bazel talk. If you've heard about Bazel in the keynote or in some of the other talks here today, and in the last couple of days, you probably have some questions like, what is this thing? Why do I care? Should I care? How does this relate to Angular? Those are the things I'm going to answer in this talk. My name is Alex. I've been at Google 10 years, which means I've done these things a fair amount. I'm the lead right now for the Angular's tooling team. And I'm probably, to you all, the Bazel guy, because that's the talk I always give. Our team owns both the Angular CLI that you all use and also the internal tools that we use at Google to build and test our own applications. And so it's really interesting for us having both of those needs that we can do more to converge them. And that is a lot of where this comes from. So I like to start all of my talks with a fake quote that I made up. So some enterprise user says, my build in CI is too slow, although I have heard this from a number of you at the conference. And this is the main motivator of what I'm going to talk about today, is the CLI works great unless you're an enterprise user, and then there are some things that we still want to make better for you. And speed is one of those things. So before I can get into even telling you what is Bazel, I want to talk about what is a build tool, because I think this has gotten really confused in the JavaScript ecosystem. So one question I get, well, I would use Bazel, but we're already using Jenkins. We don't replace Jenkins. Is this an alternative to Webpack? No, Bazel can work with Webpack. So the way I think about this is to divide the space of the tools that you use into these three columns. And a CI system, its job is to watch for changes that you're making to your app and to trigger some tool to do the build. And then in the middle column, you have like hundreds of these individual little tools that can do lots of different things. Some of them have a big job, and some of them have a very small job. Like injecting things into your index HTML is a small job, but it could still be its own tool. The third column here is a set of what I would call a build tool, because they're generalized. The only thing they know how to do is run those dev tools from the second column. And Bazel is one of those. Gulp and Grunt, which many of you probably have used in the past. Make was sort of the original tool in this space. And you can visualize this as a hub and spoke model. So Bazel, Gulp, they both fit this middle box. That's not a box, sorry. And their job is just to spawn the other tools. And in particular, like, you only need to write each of these plugins one time. So for somebody like our team, it's really useful that, that we can separate out. Like, these can be different layers in the tool chain. And so you contrast that with what has happened since Gulp became less popular. I know a lot of you are still using Gulp, but it seems like it's on the decline lately. If you don't have any of the tools from the third column, then what orchestrates your build? And the only answer is, well, the tool in the middle column has to do that work for you. And so where we end up in that model is it's a big matrix. And so for every one of your tools, every bundler, every dev server, every test runner, it ends up having to know how to do all of the different transforms that are required to go from your original sources to the app that needs to run in the browser or in Node, wherever you're up. So I did a separate talk about this at the last Modern Web Meetup that you can listen to, and I go into more detail about the difference between these two. My point about this today is just to say Bazel is distinct from any of these other tools. So your CI system calls Bazel. Bazel calls all the individual tools. So for this talk, I want to give a bit of guidance about what scale we're trying to target with Bazel. A 10-component app, what I'm calling small T-shirt size, is probably a typical app that you would write in a bootcamp class, or maybe like the Tour of Heroes or our new Getting Started that we just announced, all the way up to a 2,500 component app. I picked that number because that is actually the size of one of the Angular apps that we build internally at Google. And building an extra large app is pretty challenging. I don't know how many of you have a 2,500 component app. Probably some. I don't think Google is the only one building really large applications at an enterprise scale. And how do we do that today? So Bazel, obviously, this is the build tool that we use at Google, and we've been using it for many years to build all of our code, including our Angular code. Bazel is open sourced by a team that has come to visit us here at ng-conf. They are partnering with the Angular team to make Bazel work better for front-end builds. So what is it about Bazel that makes it work well for us? I don't have time to go through these in any detail. I encourage you to, I'll have some links at the end that you can find other talks that go into more depth on these. In short, Bazel is incremental, which means if you make a small change to your app, you should only have a small amount of rebuild or retest work to do. It does a full stack build and test. We'll talk about Angular Universal as one example, but at Google there are a lot of systems where we need both a backend and a front end to be available in order to run tests. Bazel can span your entire build. It can do Java, it can do Swagger, it can do lots of, it can include all the things that need to go into the app that you want to test. It scales on the cloud, which means that you're not constrained with the local resources. I have a demo of that at the end. And it's extensible. You can add your own things into your build. Most builds at Google are a special snowflake, and yours probably are too. And finally, my personal stamp of approval for what this is worth. I've been using Bazel since I started at Google, and it's really, really, really amazing. It's really well done software. So this is why I think it makes sense for us to explore how we can use this. Stephen, this morning in the keynote, gave you his product life cycle here. So I'm going to tell the story quickly of how we got to this place where we are with Bazel. In 2016, I had this idea. Basically, this was our Venn diagram, where Google and your tool chains are completely diverged. We weren't really sharing any code. And to make these things more similar, we need to push both bubbles. So on the one hand, we started using TypeScript at Google, which was developed outside of Google. And it's been really awesome that we get better developer productivity internally at Google by bringing in technologies. But at the same time, there's a lot of things that we use at Google that could be useful for you. And that's where Bazel comes as the other direction. So I gave this talk in Europe, and I mentioned Bazel here in 2016. And it was still just an idea. So then in 2017, we had to make a theory of this. Can we get together and agree that we think we can do it? And so to prove that, we needed to hook up Bazel and Node.js. Bazel comes from a backend. It started more with Java and C++, and so it was our job to make it be able to run Node tools. So that's what this repo does. And then I went to Angular Mix, and here I presented the slide from the previous year at NG Europe. If you like Inception, you're going to like this section of the talk. In 2018, so we went to Possible. So Possible means we can prove to you, you can fetch this repo and you can try it. And hey, it does work under this very special circumstances that the repo had at the time. And this is still the example app that I encourage you to check out if reading examples is the way that you learn things. And so this was last year at ng-conf. I wore my Bazel shirt, and then I took a picture of that, put it in my slides, and then I presented that at a workshop that we did here, where some of you, if you were here, got a chance to play around with doing a full stack build using Java and Bazel. So now here we are at 2019. I'm not going to read all of these things, but the short story is, if you tried Bazel in the past, there were a lot of sharks in the water, and so you might not have gotten in the water. The sharks have been dealt with. The water might still be cold, but we've done a lot of work to make this fit the existing model. So we've smoothed a lot of rough edges, and we've also made it scaled down to fit into a smaller project, because our usage at Google is that Bazel is used in really large projects. So for example, the Bazel team, based on our feedback, went from I think 180 megabytes for the @Bazel/Bazel npm package, and the latest number is less than 50. So they're working on trimming things out, making it fit better into our lives as front-end developers. And so now here we are in 2019. As Brad announced in the keynote, Bazel is graduating into an opt-in preview, which is the same status as Ivy. This wasn't intentional that ng-conf this year was all about opt-in previews. So this is part of Angular Labs. Let me unpack that a little bit. So just like Ivy, what we really want to learn is how compatible we can make Bazel with your existing, with your app and the toolchain that you use. And we know that it has some issues still. We have error messages that are hard to understand. The performance isn't where we want it to be yet. Some third-party libraries, we still have to do some shimming to support them. But for the most part, we think this now fits in the easy category, where you can go try this. And so the question is, should you go try this? And probably not all of you. So before I move on, the final Inception slide is here I am this year at ng-conf in 2019, showing that slide from me here last year, wearing the same Bazel shirt. I thought about wearing the Bazel shirt right now, but then you might think that that's the only shirt I ever wear. OK, so I'm going to make this a little bit less scary. I already said Bazel is just this hub and spoke model. It runs your existing tools. But let me also describe how it fits into the Angular CLI. So in the keynote, Brad announced that one of the new features we have in Angular 8 is this Builders API. And as he said, that the schematics API we released a year or so ago allows you to customize the files that the CLI will produce in your project. Builders allow you to customize what tools we run when you run ng-test, ng-build, ng-serve. And so the one you use today, you may have never seen this npm package. It's buried inside of the CLI. But it's this @Angular devkit/build Angular package. And that is a builder. And it sits in between the CLI and all of the tools that we call. And so you can think of Bazel as simply a different green box that sits in between here. It's just a different way to orchestrate which tools we run when. You still use the CLI. You can still use your existing tools. And so hopefully that makes it less scary. So let's talk about what application scale you're at. I had these T-shirts earlier. let's say you have a small app. The most important thing we want to do for small apps is stability. Igor talked about this in the keynote. We care so much about never breaking the ecosystem again because we want all of you to be able to stay on the latest version of Angular and the latest version of the CLI. And so our number one priority here is not to mess up your life. There should be no observable difference when Bazel happens. And there's really not a good reason if you have a small app that Bazel should solve any of your problems today because there's no observable difference, either bad or good. Bazel will at best do the same thing you have already. However, when we get it to medium scale, based on some benchmarks we've been running, we think that we can get a faster build and test. I'll have some graphs in a little bit. And also the full stack builds, something like with Angular Universal, we see that medium-sized apps tend to start to have these requirements. Angular Universal today in development mode is kind of hard to build because it doesn't know how to deploy the server-side parts of your code. OK, so I'm going to describe how build systems work. OK, I accidentally skipped this slide. This is an important slide. This slide intentionally looks stupid. And the reason this slide looks stupid is because it shows a very simple model of how your code comes to run inside of your app. And I want to make clear that this is entirely the correct model for you to have. You should not, don't feel bad. This is how you think it works. This is how it works. This is the whole intent of the Angular CLI, is to make it really simple for you to get your code into your app. But since we're talking about this opt-in preview, I'm going to explain a little bit how Bazel is different. So one way to think about it is Angular CLI is really just running this Node.js process. And then inside of the Node.js process, it runs one tool, like let's say Karma, and that tool has to run all the plugins. Like I said earlier, it has this plugin matrix. Bazel instead follows the Unix philosophy, which is lots of independent programs, cut, awk, sed. And then you can compose those programs in some novel and new way by piping the output of one of them through standard out into the other, or by sharing some temporary structures on disk. And all of the all of the tools in the Unix environment know how to speak in these two kind of idioms, and so it's really easy to combine them and write a one-liner that does something really powerful. You can think of Bazel doing a very similar thing for your build. So Bazel has a graph of what needs to happen, and this is the graph we give you by default when you opt into to our new preview. So you get one big compilation of the TypeScript code, and at the same time, in parallel, we can do a big compilation of the Sass code, assuming that you're using Sass, just an example. And then those are both depended on by running ngc. And finally, that's depended on by running the dev server. So when you tell Bazel to run the dev server, it walks this graph, figures out what work needs to be done, and then your dev server comes up. A couple notes here. One is that we always do AOT under Bazel, and the reason is we've always done it that way at Google. Because we have the incrementality property, we're able to get our builds fast enough, even though we have AOT on all the time. And also, this dev server just happens to be written in Go. And because Bazel is a full-stack build system, it doesn't need to have Node.js be the runtime environment for all of the tools. We wrote this in Go because we wanted it to be super fast to put lots and lots of modules into the browser. And I've benchmarked this at 10,000 very small TypeScript modules getting into the browser in 60 milliseconds. So just an example of something that Bazel allows us to do. So let's say you want to try this. And you have an app where you think it can actually solve your problems. So the simple way to get on board is, first of all, update to Angular 8. And then either create a new app using the @Angular/Bazel collection, or use that same package with ng-add to add Bazel into your existing application. And at this point, what you should expect is that you have the same behavior as before, and your sources haven't really been changed. There's just a couple of differences when we set up Bazel. And the outputs all look similar. But it doesn't yet have all the scaling properties. So this is just like your first step in, OK, let's see if Bazel can work in my project. And if you need to go back to safety, if something doesn't look right and you just want to get back to development, we make 2 backup files. You can restore them and go back to the previous builder. So I have a demo for opting in, but in the interest of time, I'm going to skip this one. If you want to look at my slides, there's a video here. What I show at the end of that video is that, OK, we ran a build before, and then we added Bazel, and then the build still works. But we get to this point where we want to scale up, and we want to break down the compilation into lots of small parts instead of that graph I showed that only had 4 nodes. Right now, this is a manual configuration step. I'll talk about how we think we can make that easier. So we do ng-build, and we pass this flag, and it will leave the configuration files on disk for me to edit. So let's take a look at a bigger scale example. This is 1,000 components. This application looks a little bit like a cloud console. It's kind of modeled on the Google Cloud Console. And the example is hosted here. And here's a graph of what this looks like. I've obviously trimmed out a lot of it. It's a much bigger graph than the one I showed before. My application at the top depends on all of these different feature sets, and the feature sets probably have a bunch of ng modules. Each ng module has a bunch of components. So there's 100 libraries, 1,000 components. Let's talk about what the build should look like before I actually show the demo. So if I edit one of the leaves here, I mentioned incrementality. What should need to be rerun? Let's say that I'm going to edit by adding a console error line to the end of the file. So it doesn't change the TypeScript type shape of this file at all. That means I don't need to type check anything up the graph. And it's a little bit of an internal detail, but we use the TypeScript DTS files as these dependency edges, which means that the only thing I expect to have to happen is to rerun this one test when I change this component. It shouldn't have to rebuild, touch any of the other nodes in the graph. This is the timing that we'll see when I run ng-test. So this is the non-incremental build. This is even if we don't have, if we have to build everything. Since Bazel is always AOT, we don't have to run the Angular compiler inside of Karma, so that gives us a speed up. And also we can shard the tests among more processes than we do today. So let me, hopefully, I have to look down here. OK, so I've pre-recorded a video because when you don't get a lot of sleep, you don't do a live demo. So here I'm in the large branch of the example repo. Let me make this bigger. And so I'm running ng-test. So what happens the first time I run ng-test is there should be nothing to do because I haven't made any changes to my app yet. So this instant ng-test is what you should expect to happen most of the time. Now I've done a console error, and I've one of these 1,000 components, I just stuck it at the end in order to make the graph dirty. You can imagine what Bazel is doing here is similar to Angular's change detection. It needs to walk this graph and figure out, for any node whose input is changed, I have to reevaluate it. And so just this test was affected, this test is running, and you can see Bazel already had 100 tests that had been reported as passed. So now the final thing I'm going to do, I'm making an edit here to this material module. And the material module is sort of my design system for all of my components, and so everything depends on this material module. When I change this, what do we expect to happen? All the tests are affected. And Bazel is able to run these in parallel using multiple processes. But I only have 4 processors on this machine. And so by default, Bazel will only run 4 of the processes at a time. And this is still kind of too slow. So let's talk about how we're going to make that faster. And I'm going to move this little picture-in-picture so you can watch that thing happen in the background if it works. It doesn't seem to work here. It worked when I was on my local screen. OK, so what I showed is, number one, your first build was cached there, right? I didn't have any work to do. Let's say that you come in the morning and you sync to head and you run a build. How can that build be cached? So we can actually host the cache in the cloud, and then you can share cache hits with your coworkers and with your CI. Probably when you come in the morning and sync to head, your CI already ran all the tests there. This is a great way to speed you up. But then when we have a cache miss, like the one where I edited the material module, we have a massive cache miss. There's actually a lot of compute to do, and our build in CI becomes compute bound. And so what we really want to do is be able to host all of those, all that work in the cloud. So when we add remote build execution, which is a service that Google Cloud provides that is a backend for Bazel that can bring up a lot of workers and spawn all these tests remotely, we see the time goes down even more. So let me show what that looks like. Notice here's our one running locally, still sitting there trying. So I'm going to play this video, and in this one, I've added one line to my Bazel RC file. Since Bazel follows the Unix philosophy, it uses RC files as your configuration. And I'm saying config equals remote, which means I'm turning on some options that are going to tell Bazel that there's a cloud of machines available to run on. So my first build, again, was incremental, although in this case it was coming from a cloud cache and not from my local cache. So I was taking advantage of the fact that the CI has already run these tests. And now when I edit this material module, what do we expect to happen? So first we have to compile the first node in the graph, which is this material module itself, where I've made the edit. And then Bazel is going to spawn all of the tests at the same time, because I have 100, I think I have 150 workers in the cloud. This is exactly the same behavior that Brad mentioned in the keynote, where Angular's own build, where we are using remote build execution for CI, went from 60 minutes to 7.5 because we were able to use 150 machines in the cloud to parallelize the work. So just to cheat on time a little bit, because I have 20 seconds left, let's skip. Obviously, all of these things start to complete. The number of actions running concurrently drops off because Bazel has no more work to do, and then it's finished. So if we compare that with what's going on with the local build, it's still way behind. Actually, it looks like I paused that video, but it would still be behind. OK, so let's talk about the future very quickly. So after version 8, we want to finish these Stephen steps of maturity for an Angular feature. So we want to get to automatic. What does that look like? We need to have Bazel be released as 1.0, which is currently planned for September. Once Bazel is 1.0, we want our Node.js support to also go to a stable release. We need to graduate from Angular Labs and feel that we can commit to a stable API for how the Bazel rules work. And then we want to make it much easier to do the scale-up steps. Like I showed in this graph, the large graph of the large application, that was all configured manually, and we want to be able to do that automatically so that Bazel can automatically scale up. Very briefly, you might remember when we introduced TypeScript, and it seemed controversial at the time, but we really felt that TypeScript gave Angular a big advantage in being able to enable your development workflows. We think that Bazel is a similarly big bet. It's not obvious that this is something that the JavaScript ecosystem needs, but we think that especially as Angular is trying to become more of a full-stack platform, and we're working with our new sister team at Google on doing more server-side rendering scenarios, we need to be able to think of Angular deployments as being both client and server. And so having a full-stack build system like this, we think, will give us a big advantage. And we've learned to be non-breaking, unlike when we introduced TypeScript. So we think this one will be better. Bazel.angular.io is our landing page. There are a bunch of resources here. You can find a link to RBE, the remote build execution, if you want to try that. Documentation is here. You can subscribe for updates. We'll let you know as we make more progress. The example app, and you can also find links to this talk and a bunch of other Bazel talks to help explain a lot of the other concepts that I breezed through as quickly as possible. That's all I have. Thank you very much.